So in this video we want to find the sum of 5 times 3 to the k minus 1 between k equals 1 up to k equals 12. We're then told hence find the value of the sum of 5 times 3 to the k minus 1 between k equals 5 up to k equals 12. So generally with the summation I always suggest you start writing out what the terms are, because it might make it a little bit easier to see if there's a quicker way of solving it. So let's start off with, we substitute k equals 1, 1 minus 1 is 0, 3 to the 0 is 1. So our first term is 5 plus, substitute k equals 2, 2 minus 1 is 1, 3 to the 1 is 3, times 5 is 15. Plus, substitute k equals 3, 3 minus 1 is 2, 3 squared is 9, times 5 is 45, and so on. Then you can look and see if there's a pattern that you recognise, and, well, you should hopefully very quickly realise that we're multiplying by 3 each time. You might be able to tell that quite easily from the expression, but that's quite an easy way to see that this is true. So if we're timesing by 3 each time and it's a series, well, that should be telling you that actually this must be a geometric series. And if it's a geometric series, we have a formula that we can use to find the sum of however many terms, or specifically the sum of the first n terms of a geometric series. So we're going to use that formula, but in order to use that formula then, we need to know a value for a, which is the first term, r, our common ratio, and then the number of terms that we're looking for. Well, because we've started to list what our terms are, our first term a is just 5. Our common ratio r, which is the second term divided by the first, but we've already found that because it's also the multiplication factor, is 3. And because we're going up from k equals 1 up to k equals 12, that tells us how many terms we're looking for. So our n value is really 12. So if we've got all of those 3 parts, we just need to substitute it into the summation formula. So we're looking for the sum of the first 12 terms, which is equal to 5 times 1 minus our r, which is 3, to the power of n, which is 12, all over 1 minus r, so 1 minus 3. 1 minus 3 is minus 2, so we have minus 5 over 2 times 1 minus 3 to the power of 12, which we can bring the minus in as a multiplication and say that's 5 over 2 times 3 to the 12, all minus 1. This is when you go to your calculator and you end up with 1,328,600. It doesn't take very long for a geometric series to go to quite large terms, especially if you're adding them. So that's our answer for part A. Part B says, hence find the value of the same sum, but this time starting at k equals 5. Well, we've already looked at what the sum is from 1 up to 12, and we still want to go up to the 12th term, but what we don't care about in part B is the first 4 terms, when k equals 1, 2, 3 and 4. So all we have to do is work out the sum of the first 12 terms, which we know, and then subtract the sum of the first 4 terms, which we don't know, but we can find. So we need to find the sum of the first 4 terms, so let's set out our values. A is still the same, that is 5. Our common ratio hasn't changed, so that's still 3. And this time our n value, because the sum of the first 4, is just 4. Sum of the first 4 terms, if we substitute in them, we have 5 times 1 minus r, which is 3 to the power of n, which is 4, over 1 minus 3. So we got minus 5 over 2. 1 minus 3 to the power of 4, which is 81. 1 minus 81 minus 80 times minus 5 over 2 gets plus 200. So we just need to bring our two parts together then. So we have 1,328,600 subtract 200, which gets us 1,328,400. And that's our solution to part B. And that's how we solve this problem, converting a sigma notation geometric series problem into using the normal summation of the first n terms of a geometric series formula.